Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion, one MCQ about the reaction of Barrelene. So this molecule is named as Barrelene. By the way student, I ask you one question. Write down the synthesis of this molecule if you know how you can prepare this reaction, this molecule in the comment box. Okay. So let's go to problem. So this molecule has three isolated double bonds. It reacts with bromine in carbon tetrachloride. And what is the major product of this reaction? So here four options are provided and one of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box. Don't worry, after some time you will get the right answer with proper explanation. By the way student, I request you for any such kind of videos, I request you please visit the description box of this video, because any related video link I post in the description box. Now if you look at this Barrelene, it is actually an isolated triene. So this is double bond 1, this is double bond 2, this is double bond 3, and it reacts with bromine. Bromine is actually an electrophilic reagent due to polarization, some bromine became delta plus, this is delta minus, and double bond can act as nucleophile and attack this thing we know, and this way reaction starts. But the products are not that much easy, you can see. So for that purpose, let's go stepwise. So first step is the reaction of bromine with carbon tetrachloride. As I told at the beginning that these bromine will react together. This is delta plus, this is delta minus. So this delta plus bromine will be attacked by this double bond and it will leave. And first there will be an attachment of bromine in one atom, for example here. Later on these okay, let me draw it here, I guess it will be better. So first step is that this is now first step. For example, let's consider bromine is attached here and this is the positive charge, because along with that bromide minus is left. Now this bromine atom has three lone pairs of electron and its size is significantly bigger, so that's why it can attack with its lone pair at here, and it can produce a three-member cationic species, that is bridge bromonium ion, and this is the intermediate. By the way, I've discussed lecture on this bridge bromonium ion in a visit for better understanding. This is actually electrophilic bromination of alkene. Now we know that in the next phase this bridge bromonium ion get attracted by this Br minus, which acting as nucleophile. But this reaction is not that much easy here. Why? Because it undergo neighboring group participation, means any one of these, one or two, any one of these alkene can attack. Okay, so it's a symmetrical molecule, so attack can happen from any side. So let's consider this attack happens from here to this one and it opens. Consequently, this carbon will have a positive charge, means electron deficiency. Now in this way a three-member ring is formed, and next time this positive charge is this positive charge got attacked by this bromide minus as nucleophile. So in this way this product is produced, and which I have drawn in a different way. I mean that, see, these two bromine are same side and opposite to that this triple bond. Now these two bromine are the same side, 1-3 relation I can say. This is 1, 2, 3. This is 1, 2, 3, and opposite to that this is the three-member ring. Now here you may have one question. Your question may be that, sir, we understand everything, but in this this ion, if you look at, so previously the cation got attacked by this alkene. Now in this case, isn't it possible? What do I mean by the statement that this double bond can attack here? Isn't it possible? Actually student, it is difficult based on my understanding. Why I'm telling you are thinking that previous case it happened, but not why in this case, because when this ring is formed, this three-member ring, the system became more and more rigid. Not only that, here you are watching that there are 1, 2 and 3 bonds. It looks like that 1 and 2 bonds are similar in length, but 3 is different. No, all 3 bonds are similar in length. Consequently, the distance between this carbon carrying positive charge and these alkene became more. So here I can say distance increases, and for that purpose proper conformational orientation is difficult to attain. So this is the thing. And another thing, remember, 3-member rings have significant amount of angle strain. Now it is true that one 3-member ring produced, that's fine, but preparing more 3-member ring, it's really difficult. It will have more angle strain. So that's why in next case this double bond will not attack this positive charge and produce another 3-member ring. So reaction will stop at this position. And by the way, I have represented this molecule in a different way. Your question may do this thing. So that's why this relative numbering case is very useful. Please remember this strategy. Now, what are the key steps and name reaction associated here? The first step is the halogenation of alkene. Actually here I can say bromination in presence of non-polar solvent like carbon tetrachloride, and it produces this bridge bromonium ion, which is the intermediate, and these bromonium ion undergo neighboring group participation or NGP, which is an intramolecular SN2 type reaction, backside attack. So in this way it produces this 3-member ring and carbocation. And next step, this nucleophilic addition of the bromide to this carbocation, which will produces this dibromo compound. And here the interesting thing, this 3-member ring. So I presented this molecule in a different way. So now what is the answer of this question? Answer of this question is option B. Now in this case, if you got this question less than 30 seconds, how can you get to the right answer? Now for that purpose, you need to understand that this is a bromination reaction and it proceeds through a bridge bromonium ion as intermediate. So I suggest you please draw the bridge bromonium ion structure. Okay, so this is, now you consider what reaction possible. Generally we observe that in the next carbon this bromine attacks, but attacking is relatively difficult because this is a ring system and significantly congested. Apart from that, there is a chance of NGP possible. So that's why this neighboring group participation possible. So that's why in such cases this NGP will happen. Now if you understand up to this much, this option gone. And second thing, I have done the reaction at room temperature, so no radical could be prepared. So that's why allylic halogenation is not possible in, so that's the option gone. Second thing, allylic halogenation proceeds through radical intermediate, and these position, student, it is called bridge head position. And bridge head position, this radical is further less stabilized. Why? Although it is allylic, but conjugation of this radical on this bridge head position with the double bond not possible, because bridge head position cannot attain planarity, so conjugation not possible. So of these option gone. Now here the question is, sir, which one will be the product, B versus D? For that purpose you need to look at the ring number 1, 2, 3, 4. Again 1, 2, 3, 4. So it's actually 2 4-member ring in this case, but here one is 3-member and another is obviously 5-member. Remember, 3-member ring formation is favored by proper conformational orientation. Actually, if two orbital wants to overlap and form a bond, they need proper conformational orientation, and that's why 3-member and 5-member ring formation is far more easier. So that's based on this logic we can conclude that this option C not possible, option B will be the right answer. Now in conclusion, what you have learned today, that Barrelene, the molecule, is actually a symmetrical, isolated, means non-conjugated, bicyclic triene 3-double bond. Bromination of alkene is electrophilic addition reaction, and bridge bromonium ion is produced here as intermediate. This bridge bromonium ion on the outside or exoside is more stable due to relatively less steric interaction. And here remember, neighboring group participation of NGP is a kind of intramolecular reaction and is always favored over their intramolecular counterpart. And finally, this 3-member ring formation is more favored here compared to 4-member ring due to proper conformational orientation and orbital overlap. So this is the end of discussion. I thank you everyone for watching. If you really consider the content of my channel is worthy, then please help this channel to grow, and if possible you may visit my 2 other channels. So stay happy, stay blessed. See you in my next video.